This is the OCR GCSE 9-1 Maths paper 4, which is a higher paper, and this paper is a calculator paper, and it's from the November 2022 series. Question number 1, part A. We have to write 65,400 in standard form. Well, we've got this 65,400, and if our decimal point is here, we need to move this decimal point 1, 2, 3, 4 spaces to the left, meaning we would have 6.54 multiplied by 10 to the power of 4. So we have 6.54 times 10 to the power of 4. For part B, we have to write 8.2 times 10 to the minus 4 as an ordinary number. We have the 8.2, and we need to move this decimal place 1, 2, 3, 4 spaces to the left, meaning we have 0.00082. So we have 0.00082. Question number 2. In 2019, Comet A and Comet B were both seen from Earth. Comet A is seen from Earth every 84 years. Comet B is seen from Earth every 105 years. We have to find the next year when both comets will be seen from Earth. Well, what we need to do here is find the lowest common multiple of 84 and 105. We can find out the prime factors of 84 and 105. 84 is equal to, if we use our calculator to type in 84, then to button, 84 is equal to 2 times 2 times 3 times 7. And if we find the factors of 105, well, if we type in 105 into our calculator and then press equals, and then the factor button, we see that 105 is equal to 3 times by 5 times by 7. So now we can find out the lowest common multiple. So to find the lowest common multiple, what we see is 3 is common to both, 7 is common to both. So for the lowest common multiple, we've got 2 times by 2 times by 5 times by 3 times by 7, and if we work this out, we would get 420 years. So now for the year, we've got this 2019, and we add on to this 420 years. And if we work this out, the year in which we see both comets from Earth at the same time, we have 2,439. So we have 2439. Question number 3. An examination has 3 papers. Paper 1 is marked out of 60, paper 2 is marked out of 40, paper 3 is marked out of 100. The 3 marks are added together to form the total mark out of 200. a student scored 65% on paper 1 and 70% on paper 2. You have to find the pass mark they need to get on paper 3 to achieve 64% of the total marks you must show you're working. What we need to do is find out how many marks we need to pass. And what we can do for that is find out 64% of the total marks, 200. So we have 0.64, in other words 64%, multiplied by 200. So if we work out what this is, we have 128. So we need 128 marks to pass. Now if we take a look at paper 1, let's see how many marks they got. Well, they've got 65% of 60. So 0.65 times by 60, that's equal to 39. So they got 39 marks on paper 1. If we take a look at paper 2, they got 70%. So we need to work out 70% of 40. So we have 0.70 times by 40, which is equal to 28. So they got 28 marks on paper 2. So if we take a look at paper 3, we've got 128 marks, which we need to pass. They got 39 on paper 1. They got 28 marks on paper 2. So the number of marks they need on paper 3 to pass is 61. So we have 61. Question number 4. A phone manufacturer records the faults that are reported. Last week, in a batch of 96 phones, 6 were reported as faulty. For part A, we have to write down the relative frequency of faulty phones in this batch. Well, out of 96, only 6 are faulty. So 6 divided by 96 is the same as 1 over 16, which is the same as 0.0625. So when we come to talk about the relative frequency, we can leave it as a fraction, a decimal, or, as I'm going to do now, leave it as a percentage. We have 6.25%. For part B, in 2020, the manufacturer sold a total of 12,321 phones. We have to work out how many of these phones the manufacturer should expect to be reported as faulty. Well, what we need to do is work out 6.25% of this total. So we have 0.0625 times by 12,321. So if we work out what this is, we get 770.06, etc. So we can expect 770 of these phones to be faulty. Question number 5. B is 12 kilometers due east of A. C is southeast of A and on a bearing of 225 degrees from B. We have to complete the diagram to show the positions of A, B and C. Show clearly the values of all 3 angles in triangle ABC. We've got this scale, 1 centimeter represents 2 kilometers. Now the first thing is B is 12 kilometers due east of it, and if we use the scale, 1 centimeter represents 2 kilometers. 12 divided by 2 is 6, so we need 6 centimeters. So if I measure from this point A 6 centimeters, we've got 1, 2, 3, 4, 5, 6. So the point B is going to be over here. So now we know that C is southeast of A. So if I think about my compass, I've got north, east, south, and west. Southeast is here, and here we've got a 45-degree angle then. So what I need to do is measure 45 degrees from A. So 45 degrees is what's shown here. And if I draw a line like so, C is going to be on this line somewhere. But we also know that C is also a bearing of 225 degrees from B. So if I think about my compass once again, I've got north, east, south, and west. I've got 180 degrees here, and to go to 225, I need an extra 45 degrees. 180 plus 45 gives the 225. Which means I need to measure an angle of 45 degrees from B. So here is that 45 degrees. And if I draw my line on like that, the point C then will be the intersection of these over here. So now that we've got all that, we've got the 45 degrees here, we've got 45 degrees here, and then we've got the 90 degrees here. So we've shown all the angles in our triangle. Question number 6 for part A. A solid block of wood is a cuboid which measures 3 centimeters by 4 centimeters by 5 centimeters. Its density is 0.65 grams per centimeters cubed. We have to work out the mass of the block of wood. Let's begin by working out volume. The volume is equal to 3 by 4 by 5. And if we work out what this is, 12 times by 5, that's 60. So we have 60 centimeters cubed. So therefore, for the mass, we have the density 0.65 grams per centimeters cubed times by 60 centimeters cubed. So if we work out what this is equal to, we get 39. So the mass is equal to 39 centimeters cubed. Part B, here are two areas. Area A, we've got 0.12 meters squared. Area B, we've got 95,000 millimeters squared. Which area is greater? Show how you decide. What we need to do is convert between the units. Now, we've got meters and we've also got millimeters. from meters to millimeters, and then from millimeters to meters, we times by 1,000, and here we would divide by 1,000. So from meters squared to millimeters squared, we times by 1,000 squared, and from millimeters squared to meters squared, we divide by 1,000 squared. So if I take a look at B, well, let's convert B into meters squared. We've got 95,000, and if I divide this by 1,000 squared, we get 0.095 meters squared. So which one is bigger, A or B? Well, clearly A is greater. And the reason for this is the 0.12 is greater than 0.095. Question number 7. Part A, we have to construct the perpendicular from the point P to the line AB. With our compass, put the pointy bit on the point P, like so. And once we do that, what we need to do is intersect this line with arcs. So we can intersect it here, and we can also intersect it here, for example. Then put the pointy bit at this intersection point, like so. And then what we are required to do is draw an arc like so, and retaining the same radius, do a similar thing from the other point of intersection, like so. And then what we need to do is join this point with this point here, with a straight line. So if we do that, we can join these points up like so. Here we have our perpendicular bisector. Part B, the diagram shows a field LMN, and we are told in this question that a tree is to be planted in the field so that it is the same distance from the fences MN and ML, and the same distance from corner M as the corner N. And we have to show by construction whether this can be done or cannot be done. So if it's supposed to be the same distance from MN and ML, I need to find the angle bisector. So put the pointy bit at the point M, like so, and then intersect the lines like this, and also like this. Then put the pointy bit at this point. Let's extend our radius and draw an arc like that. Then from this point here, draw an arc like that. So now I need to join this point with this point. So we've got this line here. And then I want it to be the same distance from this corner as this corner, so what I need to do is find the perpendicular bisector of this line. So if I put the pointy bit over here, make sure that the arc is greater than, the radius of it is going to be greater than half the line, so something like that. And then draw an arc like so, retaining the same radius. Draw another arc from the same side, like so, and then join the points. So I join this point with this point here. So where would the tree be planted? Well, the tree would be planted here, and so by construction, can this be done or can this not be done? Well, it can not be done. Question number 8. A bag contains 35 balls. Each ball is either red or green. The ratio of red balls to green balls is 3:2. We have to work out the smallest number of balls of each colour that have to be added to the bag so that the ratio of red balls to green balls becomes 7:3. I must show you working. We've got this ratio of red to green being 3:2, and in total we know we have 35. Now because we've got 5 parts, 35 divided by 5 is 7, so each part is worth 7, which means for red we've got 21, and for green we've got 14. Now if we have the ratio of red to green afterwards becoming 7:3, that means the total must be a multiple of 10. Now we've got more balls than the 35 before, so the next multiple of 10 up from 35 is 40. So what we're saying here is, if the total is 40, that means each part is going to be worth 40 divided by 10, because we've got 7 plus 3, which is 10, which is 4, meaning the total for red is 28 and the total for green is 12. But do you notice the 14 is greater than the 12? And that's not going to work because we need more green and red. So let's try the next multiple up. Let's try this time 50. The next multiple up from 40 is 50. This means each part is going to be worth 5 because we've got 50 divided by 10, which is 5. So that means the total for red then will be 35 and the total for green will be 15. Here you can see we've got more red and more green than before. So the smallest number of balls of each colour that have to be added so that the ratio becomes 73. Well, if I think about red, we would have 35 subtract 21, which is equal to 14. And if we think about green, we would have 15 subtract 14, which is 1. So that means we added 14 red and 1 green. Question number 9. Here are 2 pieces of work. For each one, we have to describe the error in the method and give the correct answer. So here, for our question, we have to rearrange y equals 3x plus 17 to make x the subject. We've got y equals 3x plus 17, and then they've rearranged to get 3x by itself, and they've written y plus 17 equals 3x, and then they've divided through by 3. So in terms of the error, well, it's over here where they've added the 17. What they should have done is subtract 17 instead. So when we have the correct answer to be written, that is simply x equals y minus 17 over 3. Next, we have to rearrange a equals 4x squared to make x the subject where x is greater than 0. Well, we start off with a equals 4x squared, then they've square rooted, so they've got the square root of a equals the square root of 4x squared. Now, they've written the square root of 4x squared as just 4x. So when we come to talk about the error, the square root of 4x squared is 2x. So the correct answer should be x equals square root of a over 2. Question number 10. You may use these kinematics formulae to answer this question. V equals u plus at and s equals ut plus a half at squared. A particle has an initial velocity of 3 meters per second. After 20 seconds, the particle has a velocity of 11 meters per second. We have to work out the distance the particle has travelled after 20 seconds. Well, we know that the initial velocity is 3 meters per second, which means u is equal to 3. We also know that we are looking at what's happening to the particle after 20 seconds, which means t equals 20, and we know that the velocity after 20 seconds is 11, which means v equals 11. Now for me to find the distance, s, I've got u, I've got t, but I don't have a. How could I find a? Well, I know I can find a from v equals u plus at. So let's do that. If we use v equals u plus at, we've got v, which is 11. This is equal to u, which is 3, plus a times by t, so we've got 20 times by a. We can find out what a is. If I subtract 3 from both sides and then divide by 20, you will find a to equal, well, we've got 11 subtract 3 divided by 20, which is 0.4. So we've got a is 0.4, u is 3, t is 20. We can use this to find out what s is. So if we use s equals ut plus a half a t squared, we've got s equals u, which is 3, times by 20 plus a half times by a times by t squared, so we multiply by 20 squared. So we've got 3 times by 20 plus a half times 0.4 times 20 squared, which is 140. So we've got s equals 140, meaning that the distance is 140 meters. Question number 11. The diagram shows 2 right-angled triangles that are joined together. All measurements are given accurate to 2 significant figures. We have to work out the value of x to an appropriate degree of accuracy, showing our working. Well, for us to find out what x is, I can recognise I've got a right-angled triangle, but I don't know this length. I can find this length recognising I've got a right-angled triangle. I've been given an angle and a length, so I can find out what this length is using trigonometry. If I call this length h, then that's equal to, well, here we've got 5.5 4 multiplied by the tangent of 42 degrees. So if we work out what h is, we get 4.86. So we have h equals 4.86, etc. So we need to find out what x is. So to find out what x is, we can use Pythagoras. We've got the 4.86, etc. squared plus the 8.3 squared, and this will equal x squared. So if I square this value and then add on 8.3 squared, it turns out x squared is equal to 92.53, etc. And therefore, if we square root, you will find x to equal 9.619, etc. centimeters. So to an appropriate degree of accuracy, we can conclude x is equal to 9.6. Question number 12. The diagram shows a sphere and a cone. We've got the sphere which has a radius of 4 centimeters, the cone which has got a radius of 15 centimeters and a height of 30 centimeters. This sphere is filled completely with water, and the same amount of water is poured into the cone. And when we pour it into the cone, we get this grey region here. We have to work out the depth, d, centimeters, of the water in the cone. You must show your working. And we've been given that the volume of sphere is 4/3 pi r cubed, and the volume of a cone is 1/3 pi r squared h. The relationship between the radius and the height, if I double the radius, I get the height. So that means the radius of this smaller cone will be d over 2. The height is double the radius. If I double d over 2, I get d. So now if I work out the volume of the sphere, I've got 4/3 pi times 4 cubed. That's 256 pi over 3. If I work out the volume of the cone, I've got 1/3 pi times by the radius squared, so I've got d over 2 squared, times by the height of d. And that's going to equal the volume of the sphere, 256 pi. I just need to solve for d now. So I've got d cubed over 4 equals 256. So 256 times 4, and then I want to cube root this. So that means d is 10.1 to one significant figure. So we end up with 10.1. Question number 13. Y is directly proportional to the square root of x. Y is 1 when x is 16. We have to find a formula for y in terms of x. Well, I know that y is equal to some constant a multiplied by the square root of x, because y is directly proportional to x. I know that when x is 16, y is 1. So if I substitute these in, we've got 1 equals a times by the square root of 16. So I've got 1 equals 4a, which means a is a quarter. So if I replace the a with a quarter, that means my formula for y in terms of x, I've got y equals a quarter times the square root of x. Question number 14. An estimate for the number of seals on an island is given by the formula p equals 5,200 multiplied by 1.02 to the power of t. P is the number of seal tiers after the start of the year 2015. The part here we have to write down the annual percentage increase in the number of seals on the island. 1.02 represents a multiplier of 2%. So the annual percentage increase is 2%. For part B, we have to use the formula to show that there may have been about 4,700 seals on the island at the start of the year 2010. From 2015 to 2010, we have 5 years. And so Now here we are going from 2015 to 2010. So t in this case will be -5 because we're going back 5 years. Therefore, p is equal to 5,200 multiplied by 1.02 to the -5. So if we work this out, we get a value of 4,709.8, etc. And therefore, this is approximately 4,700. And that's exactly what we wanted to show. Question number 15. The cumulative frequency graph shows the distribution of the ages of the members of a tennis club. For part A, the table summarizes the ages of the members of a cycling club. We've got the age and the frequency. On the graph above, you have to draw the cumulative frequency graph of the ages of the members of the cycling club. We first of all need to work out the cumulative frequency. We start off with 8. 8 plus 14 is 22. 22 plus 8 is 30. 30 plus 12 is 42. 42 plus 17 is 59. 59 plus 5 is 64. So if we plot all these points and draw a cumulative frequency graph, we get the graph shown in red. And for part B, we have to find out which club has younger members on average. Give evidence to support your decision. Well, what we can do is use the median as an average. Half of the 64 is 32, so if I draw a line across from 32 like so, then we can draw lines down. So, if I draw a line down here, we have 42. And if I draw a line down from here, we have 51. So which one is higher, 51 or 42? Well, 51 is higher, and that corresponds to the tennis. So which one has younger members? That's tennis, because the median of 51 is greater than the median of 42. Question number 16. A sales room sells various types of car. Some are electric, some are petrol, and some are both, and some are neither. The Venn diagram below shows the sales room stock of cars. A petrol car is picked at random. We have to find the probability that this car is also electric. How many in total are petrol? Well, we've got the 17 plus the 8. So 17 plus 8 is the total amount of petrol we have. And of these, how many are electric? Well, that will be the 17. So if we simplify this fraction, we end up with 17 over 25. So we have 17 over 25. Question number 17, we have to find the equation of the line through the point 45 that's perpendicular to y equals 2x minus 3. First of all, the perpendicular gradient of 2x is minus a half. So if I use y equals mx plus c, I've got 5 equals minus a half times by 4 plus c. So I've got y, which is 5, m, which is minus a half, x, which is 4. So I've got this equation here. And if I solve for c, 5 equals minus 2 plus c, so c is 7. Now that I know what c is, I know what m is. The general equation of the line, I've got y equals minus a half x plus 7. Number 18, part A. The next term in a Fibonacci sequence is found by adding together the two previous terms. For the first part, the first and second terms of a particular Fibonacci sequence are x and y. We have to show that the fourth term of the sequence can be written as x plus 2y. We have the first term, u1, which is equal to x. The second term, u2, is equal to y. The third term then, u3, that's found by adding together the two previous terms. We've got x plus y. The fourth term, u4, that's found by adding together the second term, y, with the third term, x plus y. It turns out u4 is equal to x plus 2y, and that's what we wanted to show. We are then told that the fourth term of the same Fibonacci sequence is 7, the seventh term of the sequence is 31. We have to work out the value of x and the value of y. You must show you working. Well, we know that the fourth term is 7, so u4 is equal to 7. Because we are told that the fourth term in the same Fibonacci sequence is 7. Then we know that the seventh term of the sequence is 31. So what we need to do now is find the fifth, sixth, and then seventh term. So u5 is equal to the third term, x plus y, plus the fourth term, 7. So u5 is equal to x plus y plus 7. u6 then is equal to the fourth term, which is 7, plus the fifth term, x plus y plus 7. So it turns out the sixth term is x plus y plus 14. So then for the seventh term, we've got the fifth term, x plus y plus 7, plus the sixth term, which is x plus y plus 14. So it turns out the seventh term is 2x plus 2y plus 21. And we are told that the seventh term is 31. So the seventh term of the sequence is 31. So we've got two equations. We've got x plus 2y equals 7. And then we've got this other equation, 2x plus 2y plus 21 equals 31, which we can simplify to 2x plus 2y equals 10. So then at this point, what we can do is find out what x and y is by subtracting the equations. The y's are the same. 2x subtract x is just x. 10 subtract 7 is 3. So we've got x is 3, and if that's the case, we would have 3 plus 2y equals 7. 2y equals 4. Y equals 2. So we have x is 3, y is 2. Part B. Here are the first four terms of a sequence. We've got 1, root 3, 3 and 3 root 3. We have to find an expression for the nth term. Well, the nth term, un, that's equal to our first term a multiplied by the common ratio r to the power of n minus 1. We need to find the common ratio. Now, do you notice, to go from the 1 to the root 3, we multiply by root 3. From root 3 to 3, again we multiply by root 3. And from the 3 to the 3 root 3, we multiply by the root 3. Which means our common ratio is root 3. So we've got un equals the first term 1 multiplied by the common ratio root 3 raised to the power of n minus 1. So we've got root 3 to the n minus 1. So un equals root 3 to the n minus 1. Part C. Here are the first four terms of a quadratic sequence, minus 1, 5, 13 and 23. The nth term is n squared plus bn plus c. We have to find the values of b and c. Well, if I take a look at the first term, that's when n is 1. I've got 1 squared plus b times by 1 plus c, and that's equal to minus 1. So I've got 1 plus b plus c equals minus 1. b plus c is then equal to minus 2. Let's take a look at the second term. That's when n equals 2. We have 2 squared plus b multiplied by 2 plus c equals 5. 4 plus 2b plus c equals 5. That means 2b plus c equals 1. So now if we notice we've got the same number of c's, we can subtract these equations. 2b subtract b is b. C subtract c is 0. 1 subtract negative 2 is 3. So b is 3, and with b equaling 3, we would have 3 plus c equals negative 2, which means c equals negative 5. So we have b equals 3, c equals negative 5. Question number 19, we have to describe the single transformation that maps the graph of y equals x squared onto the graph of y equals x plus 3 all squared plus 5. Here we have a translation by vector minus 3, 5. Question 20, Mrs. Sweet has 8 different milk chocolates and 9 different plain chocolates. Her daughter chooses one of the milk chocolates. Her son then chooses one of the plain chocolates. Mrs. Sweet then chooses one of the remaining chocolates. We have to work out how many different combinations of 3 chocolates they can choose. Well, if her daughter chooses one of the milk chocolates, that means there's 7 milk left. And if her son chooses one of the plain chocolates, that means there's 8 plain left. And if she then chooses one of the remaining chocolates, well, how many will be remaining? We've got 8 plus 9, which is 17 to begin with. Her daughter eats one. Her son eats one, so that means there's 15 chocolates remaining. So therefore, for the number of combinations, we would have 7 multiplied by the 8 multiplied by the 15. And if we work this out, we have 1080 combinations. So we have 1080. Question number 21. 60 people each try to solve a puzzle. The table summarizes their recorded times. And what we have to do for part A is draw a histogram to show this information. Well, the first thing we need is the class width. Here from 0 to 5 we've got a class width of 5. From 5 to 15 we've got a class width of 10. From 15 to 30 we've got a class width of 15. And from 30 to 50 we've got a class width of 20. We now need to work out the frequency density. To work out the frequency density, we divide the frequency by the class width. 12 divided by 5 is 2.4. 19 divided by 10 is 1.9. 18 divided by 15 is 1.2. 11 divided by 20 is 0.55. So now we need to plot these on our histogram. So here is our completed histogram. Part B. Those people who failed to solve the puzzle within 50 minutes were given a recorded time of 50 minutes. Nina uses mid-interval values to estimate the mean recorded time of the 60 people. We have to explain why Nina's answer is likely to be an underestimate for the mean of the actual time taken by 60 people. Well, quite simply, the mean should be higher, and that's because the people would have taken longer than 15 minutes. Question number 22, we have to solve algebraically. X squared plus y squared equals 18 and y equals x minus 6. So, we've got x squared, and if I replace the y with x minus 6, we'd have an equation just in x. So I've got x squared plus x minus 6 squared, and this is equal to 18. So I've got x squared, and if I expand the x minus 6 all squared, I would have x squared minus 12x plus 36 equals 18. So I've got 2x squared minus 12x, and then I add on 36, subtract 18, which is just 18. This is equal to 0, and if I divide by 2, I would have x squared, subtract 6x plus 9 equals 0. And what we can see then is we've got a perfect square. So we would have x minus 3 squared equals 0, because when I expand x minus 3 all squared, I get x squared minus 6x plus 9 equals 0. So that means x is equal to 3 only. Now that I know what x is, I can find out what y is. So that means y equals x minus 6, so I would have 3 minus 6, which is minus 3. So we have x is 3, y equals minus 3.